changed? How are each of these being changed? So, for example, in number 1, my vertex of that problem was 2, -4. That graph was shifted to the right 2 units and down 4. The slope is the value in front, which is 1. Number 2, that positive 1 inside tells me that my graph is going to the left 1 unit. And my vertex then becomes -1, 0. My domain is always all reals. And my range is y greater than or equal to 0. So the domain is always all reals. What's changing is your range if the graph is shifted one direction or the other. Okay, down in 3 and 4. In 3, the 1 is on the outside, therefore it's shifted up 1 unit. The 2 is on the outside, so it is also shifted up 1 unit. And then in the next one, our values are in the inside for number 5. So that takes your vertex to the left 2 units. And then in number 6, your vertex is -1, +3. So that tells you left 1 unit and up 3 units. So it takes you left 1 unit and up 3 units. So again, the idea behind absolute value functions are they are being transformed with respect to what's being changed inside those parentheses. So we are adjusting accordingly. Number 7 and 8. The 7, that negative in front of that problem tells you that this graph is reflected. So only graphs with a negative in the front are reflected. So 7 and 8 are the first ones that have been reflected in this homework assignment. Some of us thought all graphs were reflected. You are only reflected if your absolute value is a V-shaped graph open down. So again, in those first examples here, these examples in 1 through 6 are not reflected. 1 through 6 are not reflected. In 7, your key piece of information is the vertex. That vertex is 2, -2. It is shifted right 2 and down 2. So here's my vertex. My slope is altered to be down 1, right 1, and then it's symmetric. In number 8, it is -1, +4. So our vertex is to the left 1 unit and up 4 units and reflected. So our graph starts at -1, 4 and opens down. In 9 and 10, once again, both of those graphs are reflected. My vertex is coming from H and K. So again, recall that the standard form is y equals A, absolute value x minus h plus k. So if what's inside is positive, then your h value is negative. So in this case, my A is a -1, which tells me my graph is reflected. My H is a -4, which tells me my graph went left 4. And my K is a +2, which tells me my graph went up 2 units. So again, it's reflected, shifted left, and up 2. In number 10, it's reflected. The -1 on the inside tells me that my graph has been moved to the right one. So my H value is a +1. And then the 1 at the end moves my graph up 1 unit. So again, it's reflected, right 1, up 1. And then in 11 and 12, similar ideas. It is reflected. The -2 tells me right 2. The +4 tells me up 4. And again, the negative tells me it's open down like a frown and reflected. Just to reiterate, in this case, your domain is still always all reals. And your range value would be y's. Now, because it's open down, they're going to be less than or equal to the highest y value, which is 4. In number 12, you are reflected right 1 because it's negative, and down 1. That makes my vertex 1, -1. Domain is always all reals, and the range, since it's reflected, is less than or equal to. The y value for the range is always the k value, so it would be -1. So again, the range value is always the k value. It's just whether or not the range is less than or equal to or greater than or equal to. Okay? Any other questions on that homework assignment? Anything else you feel as though you needed to see from that? Let's quickly we'll go over the first couple. Ticket in the door, go ahead and take a few minutes and work on those 5 questions, kind of just answering what they are, how they are, and what they mean. So again, take a few minutes and answer 1 through 5 before we go over them. Alright, so let's talk about each of these problems in their own unique way. Number 1, how does the graph of y equals the absolute value of x plus 9 differ from the graph of y equals the absolute value of x? What's different? What's different? What's changed? So, what's changed is that this graph now has a plus 9 on the inside. This graph now has a plus 9 on the inside. What does that plus 9 do to my graph? It does. So the plus 9 on the inside moves it left because it's the opposite sign. Since it's positive, it's not right, it's left, and it's 9 units. So if we were to quickly graph that, what that would do is just take my graph, and if I went by 2s, because I'm saving space, what that would do is make my vertex 9 units to the left. Nothing else would change. The graph would open up. The graph wouldn't be up or down. It is left 9 units. Okay, number 2. How does the graph of y equals the absolute value of x minus 8 differ from the graph of y equals the absolute value of x? How are they different now? Go ahead, Colin. Exactly. So since the sign is the opposite, this is now right 8 units. So whatever is happening inside is going to move our graph left or right. So what variable do these affect? So if the equation is, or does anybody know, what is the general equation for the absolute value? Like y equals, and then what letter? If it's just in general. A. And then in general, it's x minus h plus k. So this is y equals a, absolute value x minus h plus k. That is the general form, or like the standard form of a line. That's the general form of an absolute value equation. So number 1 and number 2, what value or letter did they affect? Did they affect the a, the h, or the k? What value is different? What? H, yeah. Guys, all of these affected the H. The H is going to be our horizontal movements. It's what it moves left to right. So all of these affect the H. In number 3, we have y equals the absolute value of x minus 2 plus 4. So what has changed now? Something changed inside and outside. So what does that inside value do to my graph? What's that going to do? Is it going to go left or right, Nick? Good. It's going to go right. And how many units to the right? Perfect. What does that positive 4 do to my graph? What does that positive... Go ahead, Nick. Finish it off. Perfect. So it's right 4, up 4. What's the vertex of this equation? What is the vertex for this equation? Anybody know? Colton? Perfect. Not negative 2, though. 2, 4. Because it's right 2? Yep. So good. The vertex would be 2, 4. The vertex is always h, comma, k. Okay, number 4. Bello, tell me one of the 4 transformations. Tell me one of the 4 things that's happening to that graph. Sure, you can tell me the vertex. What's my vertex? Awesome, you gave me 2 of the 4. So she said it's right 5 and down 11. So it's right 5 and down 11. There are 2 more transformations. Who can tell me another one? All right, Colton? It's flipped, exactly. So the negative in the front would flip my graph. The fancy math word for flipping is reflected. The fancy math word for flipping is reflected. Can anybody tell me what that 3 is going to do to my graph? Can anybody tell me what that 3 is going to do to my graph? What's that 3 going to do to my graph? Or, sorry, the 3. Go ahead. That is my slope, exactly. So that is the slope. So the slope of this graph is 3. What that means is my graph is stretched. It's going to become more narrow. So the graph is going to become narrower. So it is going to be taller and quicker. Can't quite go down 11 with that graph. So it is right 5, down 11, and skinny. Okay, number 5. Let's see, who haven't I heard from? Jordan, give me one of the 4 transformations. Perfect. It is down 5. Okay, Reese, give me another one. Awesome. It is left 7. Okay, Zach, give me another. Perfect. My slope is negative 1/7. Okay, Max, tell me something else. Awesome. It is reflected. Okay, Joseph, can you tell me my vertex? Flip it. Perfect. And negative 5. So the vertex is negative 7, negative 5. So again, the vertex is H, comma, K. So in this case, if H is positive, my vertex is always negative, and whatever the value of the K is, so is my vertex. So it's reflected down and left. We know our slope. There's one more word I need to describe this graph. Lindsay, do you happen to know it? The opposite of stretched. So some graphs are stretched. What? Perfect. It's compressed. So guys, this is compressed because it is a fraction that is between 0 and 1. So that 1/7, it's kind of like saying, okay, this graph is only going to go, if it was in the parent form, not move down or left, it's only going up 1 and over 7. It would be like really, 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 well, that was very uneven, but it would be really smushed down from the original. All right, so what we're going to do to practice for tomorrow is you're going to do the 1 through 6 on the next page. That 1 through 6 is all about matching the graphs by identifying their coordinates and other information. And then you're also going to do the back. So you're basically doing 1 through 12, but the directions for like each one changes. 1 to 6 is matching the coordinates and its vertex. 7 to 12 is matching the graphs. All of the answers that you're using, all of your choices are back here. They're A through L. So in 1 to 12, you're basically giving me A through L. You're putting one of those letters down. It is a simple matching type problem. Does that make sense? Awesome. So tomorrow when we start class, you're actually going to be like inputting those answers, and then we'll do this review worksheet together in class tomorrow and continue our focus on absolute values throughout the remainder of the week.